Okay, these are the Chapter 1, Lesson 3 notes on scientific inquiry and scientific method. Scientific inquiry is the way scientists study the natural world and propose explanations based off of evidence they have gathered. The scientific method. The scientific method has 5 steps. The first step is posing a question about an observation. Okay, so something that you want to research and you want to find out more information, if more information is already known. So you see something out in the natural world and you want to know maybe why it happens. You pose a question. The second step is to develop a hypothesis. A hypothesis should answer your question. Okay, a hypothesis is not a fact. It must be testable, and it must be written in an if-then statement or form. Step 3 is to design a controlled experiment. This needs to produce the kind of data that will answer your question. It needs to be measurable. Controlling the variable can only have one changing variable. That's what it means. So you can only change one thing in your experiment for it to be a controlled experiment. Data collection. Decide what observations you will make and what data you will collect. In step 5, you're going to draw conclusions. Okay, that's a summary of what you learned about the experiment. Examine your data objectively to see if it supports your hypothesis. Repeat your experiment to see if you get the same results. A conclusion is unreliable if it comes from an experiment with results that cannot be repeated. Many trials are needed before a hypothesis can be accepted. And the last step of the scientific method is to communicate your results. Okay, that could be sharing it with another scientist, sharing it with the public, sharing it with media. There's 2 different types of scientific data. It could be a theory, which is a well-tested and widely accepted idea that scientists believe but has not been proven. Okay, so something that is widely accepted, but it's not necessarily proven. Okay, a law, an example of a theory would be like the theory of Pangea, okay, where all the continents used to be connected. Okay, that's a theory. We don't have any data to prove that yet. A law describes what scientists expect to happen every time under certain conditions. An example of that would be gravity. Okay, every single time you drop something or you let go of something, it drops to the ground because of gravity. That is a law. Okay, so that's the difference between a theory and a law. Okay, I have an experiment or a question that I had and formed a hypothesis, and I want to take you through that process. My question was, how observant is my 4-year-old? That's what I want to know. I feel like he's pretty observant, so I wanted to test it really. How observant was he, or is he? So my hypothesis was, if I drop $1 on the floor, he will pick it up the first time that he walks by it, or he will notice it the first time that he walks by it. So you can see here, I've laid the $1 right there, and he is about to be coming up the stairs, and you'll watch what happens. This is my experiment, okay? Okay, so my hypothesis was incorrect. So now I'm analyzing my data at this point. My hypothesis was incorrect because he did not see that dollar like I thought he would the first time that he walked by it. Okay, so going back to the scientific method, my question was, how observant is my 4-year-old? That was my posing question. My hypothesis then was, if I place a dollar on the floor, my son will pick it up or notice it the first time that he walks by it. So I designed my controlled experiment. I collected my data by going through the experiment. And now afterwards, I can look at the video and I can decide whether he noticed it the first time. And also with talking to him, I found out that he did not notice it the first time. So I was able to draw conclusions that he's not quite as observant as I thought. Okay, and then I could communicate my results by telling my husband. I could tell another, come to school and tell Mr. Miller. I could go on Facebook and post it. Those are ways to communicate my results. So that's me taking that question that I had and going all the way through the scientific method.